In this video, we'll work step by step to draw Lewis structures for two example compounds. There are 5 steps in drawing Lewis structures, and we're going to apply those 5 steps in our first compound, CCl4. The first step in drawing a Lewis structure is to arrange the atoms in the order that they will bond. Now, usually, the way we write a chemical formula, the atom written first occupies a central position in the compound. So in this case, we'll put a C in the center, and then we'll just neatly place the 4 chlorines around it. In our second step, we're going to add up the valence electrons in this compound. And when we do this, we want to make sure that we account for charges. The CCl4 is a neutral compound, so we don't have to worry about the charge here. I'm just going to use the periodic table and find carbon in the carbon group, and it will have 4 valence electrons. Each chlorine has 7 valence electrons. So 7 times 4 is 28, plus 4 gives us a total of 32 electrons for this structure. In the third step, we're going to start distributing these 32 electrons, and we're going to do that by adding a single bond between the central atom, or in this case carbon, and all of the outside atoms, or the chlorines. So 1 bond between each chlorine and the carbon. Now we want to make sure we keep track of the electrons we're using, so each one of those bonds uses 2 electrons, and there are 4 bonds, so 32 minus 8 is 24. So I have 24 electrons remaining to place in my structure. In our fourth step, we're going to start distributing those 24 electrons, and we're going to do that by completing the octet for each chlorine. So each chlorine already has 2 electrons in the bond, so we're going to add 6 non-bonding electrons to each chlorine as 3 pairs of dots. So we'll do this for each chlorine. And again, when we're done, we want to keep track of the electrons that we've used. Each chlorine gets 6 non-bonding electrons, and then the 2 electrons in the bond bring us to a total of 8 for the chlorine. So in placing those 6 dots around the 4 chlorines, we used all 24 electrons. So our electron total is now 0. Our 5th step for Lewis structures is an if necessary step. So once our electron count reaches 0, we want to double check our structure and see if we need to add a double bond. In this case, no double bond is needed because all of the chlorines and the carbon are fulfilling the octet rule. If we've used all of the electrons and everything has a full octet, then our structure is complete. Let's work through these same 5 steps with a different compound. We're going to see some differences between this compound and CCl4. Let's draw the Lewis structure of nitrate, or NO3, with a -1 charge. Again, we're going to start by arranging these atoms in the order that they'll bond. Nitrogen is central, and the 3 oxygens around it. We're going to add up the valence electrons for this compound, and in this case we do have a charge of -1, so we're going to add an additional electron to the total. So nitrogen has 5 valence electrons, each oxygen has 6 valence electrons, and then the charge is a -1, so that means that there's an additional electron present in this structure. So 5 plus 18 plus 1 brings us a total of 24 electrons to distribute in this compound. We're going to start distributing these electrons by single bonding the nitrogen to each oxygen. And again, we want to keep track of the electrons that we're using. So each of those bonds uses 2 electrons, and we formed 3 single bonds. That means we've used a total of 6 electrons, and we have 18 electrons remaining to place in our structure. In our 4th step, we're going to complete the octet for the oxygens. So each oxygen is identical in the structure. It has 2 electrons from the bond. So we're going to add 6 non-bonding electrons to each oxygen. And we're going to do that in 3 pairs of electrons. We add the dots to each oxygen here. So again, 6 non-bonding electrons plus the 2 in the bond brings the total for each oxygen to 8. And once again, we want to make sure that we keep track of our electrons. So we've used 6 electrons on each oxygen for 3 oxygens. 6 times 3 is 18. 18 minus 18 is 0. So we've used all of our electrons for this structure. So now we're at a point where we have no electrons left, but if we look closely at our structure, we'll notice that nitrogen isn't fulfilling the octet rule. Nitrogen only has 3 single bonds, which brings it to a total of 6 electrons. We're going to use a double bond to complete the octet for nitrogen because we don't have any more electrons to give it. So in this case, we're going to move a non-bonding pair of electrons from one of the oxygens into a bond so that those electrons are shared between the oxygen and the nitrogen. Now, it doesn't matter which pair of electrons you use or which oxygen it comes from, we just need to form one double bond. So now nitrogen has 2 single bonds and 1 double bond, which brings it to a total of 8 electrons and fulfills the octet rule. So the lesson here is to be really intentional with your double and triple bonding because it's not always necessary. If you want to see some more worked examples of Lewis structures, check out this video.